Hello, everybody. I'm going to be introducing you to the Build an Atom activity for Mr. Deitch's online chemistry class. As you can see here, just like many other times, it gives you your rubric of the things that you will be graded on, whether you don't do a very good job to you do a very good job over on that side. And for those who do even beyond what I expect, you're at the end. Make sure to type in your names here. Remember, just double click on the line and type. Remember, for these assignments, you should be color coding your names. So one of you should take blue, one should take red, one should take green. Try to make them very different so it's easy for your old teacher to be able to take a look and figure out who did what. And remember, each of you are supposed to do a decent section of the assignment as well as communicate with each other during the whole thing. I highly recommend doing the whole thing in real time together via Zoom or Teams or FaceTime or some other platform like that. But if you can't do that, you can do it piecemeal. Just make sure that you make comments to each other. I'm going to briefly go over this assignment for you, so let's do it. All right, so remember to rename your assignment as, week 5, build an atom with your last names and then the class code. Class code can be found by clicking this link over there if you forget how to do it. All right, then these are your directions that are done in this visual. You're going to be starting on symbol, which is this one here. You can take a look at atom as well, as that kind of just shows you these two pieces a little more clearly, but symbol is really where you're going to want to spend most of your time. You're going to take these various dots representing protons, neutrons, and electrons respectively and drag them into the center. I recommend sticking on orbits. Definitely click the unstable stable, and if you have to reset, that's the reset button. You're going to want to end on the game, which is right over there. You're going to start by making a stable neutral carbon atom. Stable neutral carbon atom. And we're just going to call stable neutral atoms atoms from now on. But a stable neutron carbon atom is what you need to make, and you're going to do that by dragging protons, neutrons, and electrons from their baskets to figure that out. So here we are at the build an atom. You go to symbol, double click that, and here you go. Make sure you click stable or unstable. And you're just going to sit there and keep dragging these things in. And notice as you do that, it changes. It says if it's neutral or positive or negative. It says what it is. It says if it is stable or not. And if you make it unstable, it'll start to vibrate around because it will break apart. And the symbol is here with the mass in the upper left and the charge in the upper right as per normal. And you're just going to keep dragging things over however you want in order for you to make a neutral, stable carbon atom. You'll also notice up here, it'll tell you the elements, and you want to get to C right over there, which is carbon. So it might take a little bit for you to do, and if you get it done, beautiful. You should then have how many protons, how many electrons, and how many neutrons. Remember, you can just double click the lines and type right in there. That's why it's set that way. Feel free to comment on it if you need people to check your work or if you have a question for them. You're then going to add 2 protons to the atom and list 4 things that happened when you did that. You're then going to put the 2 protons back into the basket, which should get you to the original carbon atom. You're going to want that to then add 2 electrons, describe what happened, remove all electrons, describe what happened, and then you just made what is called an ion. You need your definition based on what you did in steps 3 and 4 here, Google's definition, which you just search ion under Google, and my definition, which you can get from the class notes of what is an ion. All right, make sure you return to the stable neutral carbon atom. Once you do so, return to, if you cannot figure that out, just go back to the earlier steps and see how you did it in the first place. I'm just going to bold those. There we go. Add 2 neutrons to that atom. See what happens as you added. Get rid of all neutrons, record what added, and then you just made what is known as an isotope. So what is the definition you decide you've come up with based on what you've done? What is Google's definition and what is my definition based on class notes? Then explain the differences between an atom, an ion, and an isotope below. You then get to apply your knowledge. Now, for this section, it is my, how do I put this? It is my command for each of you to at least do one of these. I should see each of you doing one of these here. There are 4 of them, sorry, 5 of them, my apologies. I added a 5th one this year. for you to do. Each of you have to do at least one. How you break up the rest, I do not care. Then you have these evaluation questions. Doing these questions, you should use both your class notes. Oh, sorry about that. You can see here that there are bits of advice that I have for you. You are going to use your class notes and the animation to answer all of the stuff below. I, again, double click and replace as you go through all of these various questions. When you're all done this, and notice it's 2 pages long, you'll get to this area here, which talks to you about, is it an isotope, is it the same atom, or is it different? And I color-coded them for you. So isotopes should be done in red, same atoms should be done in blue. So such as if you look at B, which is the second one, you've got carbon-12 versus 12,6C. These are actually the same thing because carbon-12 means it is carbon with a mass of 12, and that's what this little 12 up here means, and the big C means carbon. So what you would do is you would copy this over and you would write that it is blue the same. And you should color code it however it is that you do. So I'm going to color code this one to black. It's because this is the one that Mr. D did for you. And I'm going to give it just a very light shading there to separate, make you call out to it a little. But you just write down that it is, and the answer to this one is blue. But then again, I'm going to want you to answer that. So if you watch the video, congratulations, you just got an answer I just gave to you. Even if it is being a bit of a pain for me to get it back. I can do this. Okay, there we go. Now, then there are all these questions about the periodic table. You should look at your table. The table that you should have gotten when you joined this class was pre-printed out for you and placed in your textbook. And if you did not get that, you can find it under course information on Schoology, or you can download one yourself. I highly recommend for this class that you use my table. My table is great. I have requests for it from all sorts of students who graduate and go to college. It is fantastic. So please use the great tool that I have provided for you. Then you have these games. Now, I have space for 5 group members to be able to play this game, but you probably don't have 5. You probably either have 3 group members or 4 group members, depending upon how it's set up. In that case, you just do each of these. Each group member does their own. Feel free to use the colors that are already here of red, orange, green, blue, and violet for everything that you do in this project. It's up to you. If not, feel free to change the colors as you wish. It is your decision. When you do the game, though, you're going to go back to your build an atom, and what you're going to do is you're going to click this thing here, game. And when you do that, you have got these games. Click the timer on over here, so that way you will be timed, and then play the game. So this thing asked me to find the element. Now, I know, because the elements are all based on these little red dots called protons, that there's one of them, which means this is hydrogen. Now, to tell me if it's neutral, well, that depends on how many blue electrons and red protons there are. Blue electrons are negative, red protons are positive. There is too many of the blues, so this would be an ion, specifically a negative one. I hit check, and it says I did it with 2 points, and this will continue. I go to next, and I continue going through there. At 5, I have boron, and protons and neutrons and electrons are equal, so that would be neutral. I hit check, and you just do this over and over again as you go, getting either the right or the wrong answer. Now, if you get the wrong answer, such as what I'm doing here, it just gives you a frowny face, but you can try again if you want. And if you get it right the second time, let's see, this is beryllium and it is neutral, you get 1 point as opposed to 2, but it's still worth doing. Now, if you mess up multiple times, such as what I'm doing now, just putting things randomly, it'll show you the answer after the second one, so that way you're still learning. And again, you can play these games over and over again. It'll give you a score, it'll give you the time, and then you can continue. It'll show the best you did, and you can just keep going as you go. This way, you can take care of all of these. You've got the count the element, the find the element, count the weight, symbol match, and random questions, which is probably my favorite to do. But this gives you an awful lot of exploration to your atoms. And like I said, you should be in groups of 2 to 4 when you do this one, and everything should be fine. If there is a problem, remember to send me an email. If a group member is not doing their work, make sure you leave a section for them to participate in, such as if you're in a group of 3 and one person doesn't do it, I would recommend leaving them 2 questions on the applying your knowledge blank, and I would end up leaving like 3 questions at least in the evaluation, probably 4. But that is just what I would do and what I expect you to do. Remember, if you have an absent person, you are to leave them a sizable group of work, but not quite the same amount. They will be coming into it later after all. And remember, the due dates, keep your eyes on them. Take care. Email me if you need anything, and leave nothing blank. Bye, and good luck.